everyone. Yes, I have tried very much to fit in with the JSConf pink theme. Unfortunately, I couldn't find a hairdresser to dye my hair the perfect shade of FF0088, but we'll get there in the end. So I'm going to be talking to you today about how to design for displays that don't exist yet. Now, I work as a research technologist at the BBC's R&D department. The BBC is the UK's public broadcaster, and not many people realise that it has an R&D department, but it's the part of the organisation that's responsible for investigating any kind of new technology that might be of interest to the broadcasting industry. So that could be anything from new kinds of cameras, to novel distribution methods, to novel web experiences. And I work at the user experience section, which is towards the end of the broadcasting chain. And we work on short-term projects such as contributing to industry standards or enhancing day-to-day BBC services, but also mid-term projects that might reach the audience within a few years' time, all the way up to the kind of more futuristic blue sky thinking stuff, which is the kind of thing I'm talking to you about today. And it's the stuff that I'm talking about is what we expect to reach the consumer in about 20 years' time. I'm part of a small team currently working on a project called Unconventional Screens, and we're trying to anticipate emerging unusual display technology and create cool user experiences for them. But because a lot of these displays don't actually exist yet, that can be a little tricky. But before I explain how we've approached that problem, let me remind you of how the screens we all use have evolved, and hopefully as developers and designers this will all sound pretty familiar. So going back to the early 2000s, people began consuming a lot of content on the web, and everyone was pretty much using the same device for this, some kind of computer monitor, whether that was a laptop or a desktop. And so that sounds pretty straightforward, but unfortunately, browsers played fast and loose with the rules of interpreting HTML and JavaScript, and that meant it was almost impossible to get your website looking consistent across all browsers. And that was a problem of cross-browser compatibility, which I'm sure you're all very familiar with. So things began to improve. Browsers got a little bit more sensible about how they interpreted web content. So it finally seemed like things were getting simpler. Unfortunately, it wasn't quite so easy. Just as desktop browsers were getting their act together, people started to use all kinds of new devices to consume web content. So suddenly, developers were having to deal with mobiles, tablets, TVs, all sorts of things. And because no one wants to look at a website designed for a giant computer monitor on a tiny mobile screen, suddenly the problem wasn't how to get the content looking the same everywhere, but how to get content to optimize for the type of device you're using. And that was the dawn of responsive design, and I'll talk a little bit more about that later and explain how we think JavaScript can help push it even further. So I don't want to be the bringer of bad news, but I'm afraid that this problem is only going to get worse. So we've got things like smart watches, Google Glass, Oculus Rifts, digital T-shirts, flexible displays, LED flooring, massive video walls, smart fridges, Pico projectors. Don't know what that is, but it's pretty cool. Screens are getting weirder. So yeah, the screens we're designing for are getting weirder and weirder, and we all thought a few different size rectangles was bad. So not only are we going to have to make our content look beautiful across these unconventional screens, we also need to think about the kind of content that's appropriate for each sort of device, because you're probably not going to want the same sort of content displayed on your smart watch as you do on your smart wallpaper. So that might sound pretty daunting. How on earth can we be expected to be preparing cool stuff for these devices when they don't even exist yet? So the first thing is, don't panic. There are a few things you can do that make the process not only a little less daunting, but actually pretty fun. Because it should be fun, this is the future, and the future is cool. So I'm going to talk you through our approach to this problem by using our smart wallpaper project as a case study. And I'll tell you how we went from a blank sheet of paper to kind of a working prototype, and what we're going to do with it now that we've built it. And I'm hoping that by sharing the approach that we find useful, you might go away with some kind of inspiration as to how to make your more unconventional ideas a reality. So this all started with the question, what if you could paper the walls of your home with flexible electronic wallpaper? So that might sound a bit like science fiction, but if you look at current trends towards larger displays, flexible displays, we reckon that it's actually something that could be pretty likely within about 20 years' time. So just to be clear, the BBC aren't trying to actually physically make the wallpaper. That's the job of manufacturers. What we're trying to do is anticipate and test cool user experiences that would enrich the lives of our audience, and then we can be ready for the technology when it emerges. And we're pretty lucky at the BBC because, unlike other companies that have to be kind of concerned with profit and proprietary technology, we've got the freedom to focus on providing the best user experience for our audience, focusing on principles like openness and innovation. So my first tip for you is to try and take a user experience-led design approach. So we let user experience drive our ideas and not the available technology. So while certain companies have done very well with that in the past, the sort of traditional approach for technology and engineering companies has been to do it the other way around. So they'll put loads of time and effort and money into developing some really cool hardware, and they say, right, this is great, but what are we going to do with it? And a really good example of that is TV internet browsers. Everyone got really excited that they had invented TVs that could connect to the internet, but they completely overlooked the user experience side of things. And that meant that the technology was clunky to use and provided no additional value to your TV viewing experience, so it just didn't take off. So we're advocating an approach that has kind of typically been the role of science fiction. It's all about thinking big and futuristically, demonstrating what you could do with that stuff if it existed. So in the case of smart wallpaper, we want to show off our prototype in the hope that this will kind of create an appetite for the technology, pushing manufacturers into developing it sooner than they may otherwise have done. So what does this mean in practice? You need to have a really open discussion, teasing out all your ideas, no matter how ridiculous, about how the technology might be used. And it's really important not to censor yourself or anyone else at that stage. You're trying to be as divergent as possible. No idea is too silly. So after we'd done that, we got together and converged our ideas down into the ones that seemed the most plausible, but also most engaging. And we then hired a designer to turn our ideas into mock-ups. So I'll show you some of them now. So this is what your living room might look like after you've just papered it with your plain smart wallpaper. But then you switch on the television and start watching Glastonbury. So here we were experimenting with the concept of augmenting programs that we broadcast with extra data. The stuff that at the moment might clog up the screen, but now we're kind of pushing it out and giving the screen more real estate. But we're not just looking at the living room. This is when we were trying to think about how smart wallpaper might apply to a teenager's bedroom. So the BBC provides a lot of educational services, and we began to think about how those resources might be presented on smart wallpaper. So while this teenager's revising, they can see infographics relating to whatever they're watching on the researching on the computer, and they can scribble notes down on a device and send them up to the wall. Once they've finished revising, they can turn on their favorite radio channel, and their wall will transform, giving posters of their favorite artists, a virtual window onto a live gig, and an Instagram feed relating to whatever they're listening to. A lot of people regularly check BBC weather and travel updates in the morning, and we figured the best place for that was your kitchen while you're having breakfast. Then when you get back from work, we could use the wall to display steps for your chosen recipe, and you can cook along with TV chefs. Back in the living room, somebody's watching a daytime magazine show. So on the wall, we can display a virtual bookcase filled with books that are being talked about on the show, and virtual picture frames filled with interesting works of art for you to discuss with your family and friends. Another idea we had was how we might build up anticipation for a major broadcasting event, for example, the 50th anniversary of Doctor Who. So over the space of a few hours or even a few days, you could get your whole room to transform to get you into the mood. So in this slide, we've got a virtual window giving you a view out onto another planet. Then the Doctor starts appearing in your family photographs. Then you get a nice spacey wall. And then you get scary characters creeping up on you. And then finally, you're transported into the world of Doctor Who. So they're just some of the ideas that we had when we concentrated on creating exciting user experiences and didn't worry too much about whether they'd be possible or how we'd do it. So that brings me to the second principle we tried to stick to. And that is, try to stay agnostic to underlying hardware. We wanted to make sure that anything we created would work however the technology evolves. In the case of smart wallpaper, we don't know if it's going to be a touch screen, we don't know if it'll be a giant video screen, whether it'll be made up of tiles of displays, or something more akin to e-ink. And we actually think the e-ink option is probably more likely, as it's less obtrusive than a giant, brightly lit, power-hungry monitor. But that also makes it a bit more challenging, because we have to think about the types of content that would suit a device with low refresh rates, low power, and non-backlit. But we found that having restrictions like that actually makes you think a bit more creatively, and we ended up with more novel use cases than just, let's watch a giant video on the wall. So how do you go about prototyping experiences, trying to remain agnostic to hardware when you don't know the capabilities of your technology? Well, it's good news for you. We recommend using standard web technologies. So we can be pretty sure that any new devices that get developed will use internet protocols and be web connected in some way. And that's super helpful, not only because we don't have to know exactly how the technology will evolve, but also because it means our work will apply at every step along the way to getting there. So with smart wallpaper, it's going to be a gradual thing. We're not going to leap from nothing to suddenly your whole room covered in it. People are getting more screens around their house, bigger screens, screens in the kitchen, smart mirrors, smart windows. And as long as they all have a browser, there's no reason why the experiences we're creating for smart wallpaper can't be adapted for those in the meantime. So we wrote our smart wallpaper application using HTML5 canvas and JavaScript with a RESTful API and a Node.js backend. And we spent a lot of time designing the architecture of the system to make it as flexible as possible. Unfortunately, I don't have time to go into that now, but come and ask me about it if you're interested. But the point is that using these technologies means that anything with a browser can pretend to be a wall. Given that browser-enabled wallpaper doesn't exist yet, we had to fake it as best as we could, and we used 2 giant back projector screens. We then connected each projector to a Mac Mini and got it to display a full-screen browser. We then prod the server to interact with the wall and change what's on display. So by that point, we had something that approximates a kind of a smart wallpaper working prototype. So we made a film of it. So I'm going to show you the film, and you'll see how we took some of the designer's mock-up images and turned them into a real interactive experience. Oh, yeah, I tried to embed it in Reveal, but that didn't work, so just ignore that. And the reason I wanted to show you that was it's kind of showing you how you can start off with an idea that seems a bit off the wall and abstract, but by being a bit resourceful with your prototyping, you can get something that approximates your goal pretty well. And we're a relatively small team. There are only 3 of us working on it, and we've only been doing it for a few months. But because we chose to use web technologies, we were able to move to prototype really quickly. So what's next for us? Well, we've got a lot of experimenting to do, and some people find it a bit unusual that we're using JavaScript as a language for experimental research purposes, as it's kind of mostly used as a means for creating user-facing products. But a lot of us in user experience are really keen on it. Unlike a compiled language, code changes are instantly reflected, making it ideal for rapid prototyping. And there are so many APIs and libraries that connect with novel hardware that comes out that it means that you can start experimenting as soon as these things become available. So earlier I mentioned the difficulty of getting content to display appropriately across all kinds of devices, and that as our screens change, that's going to get even trickier. So our next major research area is how we can use JavaScript to push the concepts of responsive design so that they can be applied to unconventional screens. So just to remind you of what we mean by responsive design, responsive websites provide continuity between different viewing contexts, remaining completely agnostic to the type of device used and the size of the screen it has. So in the context of smart wallpaper, we don't want the user to have to manually position everything they want up on their wall. We need ways of making it the content automatically flow and fit around the fact that all their furniture, taking into account the fact that people have different shapes and sizes of walls, they've got roofs in the way, they've got pictures on them, so that it's not just dealing with rectangles anymore. So we can do a lot of responsive design in CSS, and there are also a lot of JavaScript libraries like Masonry, Packery, some jQuery ones, and they do a really good job of dynamically packing rectangular elements into a rectangular space. But unfortunately, rectangles are not enough. Our unconventional screens can be all sorts of shapes and sizes, as can the content elements that we want to appear on them. So we need to be experimenting with new algorithms and creating more novel JavaScript libraries. So at the moment, what we're doing is building a web-based tool for testing out different layout algorithms. And one promising approach we're looking at is bin packing, and that's an algorithm that's already widely used for creating sprite sheets. So for those of you who don't know, bin packing is a computational problem that involves finding the most efficient way of packing in different shapes into a sort of bounding area. And it's what's known as NP-hard, and that basically means that there's no kind of straightforward algorithm to solve it. It's basically a brute force approach, and as the complexity or as the sort of size of your problem increases, the complexity the brute force approach just becomes unsustainable. But there are certain heuristics that you can use that sort of help with it, like trying to place the larger shape first and place the little ones around it. But for smart wallpaper, we're not primarily concerned with fitting as many things on the wall as we possibly can. We're more concerned about trying to place things in an aesthetically pleasing way. So as inspiration for how to do that, we looked at some of the ways that people currently arrange things on their walls at home. And that's actually made us start thinking about using algorithms that are used in data visualization, so things like clustering or force-based layouts, and wondering whether they could be a good approach in combination with bin packing to sort of replicate that human design input. So it's going to be really interesting to find out for us what principles we can take from computer science algorithms like those and apply them in the context of visual design. I'm hopefully going to write a blog post about our initial thoughts on that soon, so keep an eye out for that if you're interested. But in the meantime, if anyone fancies having a go at writing some responsive design JavaScript libraries for those algorithms, then that would be really helpful. OK, so where does this leave you? Screens are changing, and as developers and designers, you're probably going to have to deal with that. So start thinking about how we can create extreme responsive design, taking inspiration from algorithms that apply in other contexts. But don't panic, because JavaScript is awesome. Our team sees it as a really flexible tool for prototyping, and we reckon it's a pretty future-proof choice. Be playful, try and prototype your weird ideas, and experiment with them. And if you want to be ahead of the curve, think about the user experience and let the technology catch up with you later. And most importantly, watch a load of sci-fi. Thank you.